And as Brian mentioned earlier, I should thank everyone to coming to something that is not WhatsApp. So there's also a Haskell tutorial happening right now. Okay, so LFE. This is one of the more exotic and lesser known parts of the Erlang community. I want to go over just very briefly what you're going to be seeing, the ground we're going to cover during this talk. There's a bunch of things I want to cover. I'm going to try and cram it all in here. I'll try to leave time for questions as well. It's not all code. I want to give a little bit of background on Lisp, and why would you want to use Lisp? The historical context for this. I want to show you what it looks like and get a sense of the language itself syntactically, and then maybe we can take it for a little drive. If we have time, I hope to show you some larger projects and what those look like in LFE. And then there are things I didn't get a chance to dive into and some tantalizing things that I'd like to touch on at the very end. And then, of course, we'll do a quick summary. The big question everybody always asks is why Lisp? And there's lots of discussion about this in any Lisp book you buy. They will devote like the first several chapters sometimes to why Lisp. This is a fairly, as a result of the AI winter, this became something that people felt they had to do every time a Lisp book came out. You don't hear as many complaints as you used to about Lisp. It has become quite popular recently. But still, I should answer the question, why are we looking at it? This is a 50-year-old piece of technology, 1958. And a lot's happened in that time. We're looking at 50s, 60s, 70s, and of course, the 80s, the infamous 80s. What does this have to do? It's our second oldest programming language currently in use, and what does this have to do with the modern world? Do we even need it? You've seen things with Ruby and Python and Perl taking over the space where Lisp used to dominate, where you didn't have to have a compiled language. That, by the way, that slide was from a presentation that was given on High, which is a Python-flavored Lisp. Alan Kay said some beautiful things about Lisp. There's some nice quotes here. The power of scripting languages, which Lisp really had a strong hold in the 70s and 80s, is in their specificity. It's kind of like a DSL for programmers who think in a very particular way. But Lisp is actually a bit of a different beast. It can suit that purpose because it can suit essentially any purpose. But its power comes from the other end of the spectrum. It's a tool for the generalist. It allows generalists to design and create the things that they need. Alan Kay's fantastic summary is that the code that he was referring to in page 13 of the Lisp 1.5 manual is that in half a page you have something that can describe the entire language itself. And he refers to these, as you can see, as Maxwell's equations for software. And that's quite beautiful. He also references it as something he could put his hand over, and interestingly enough, that's the same sort of metaphor you hear a parent talking about the miracle of their newborn child. Here is the first half, and this second slide is the second half of that code. Note that this is actually M expressions, not Lisp proper. Lisp was originally thought, John McCarthy wanted to actually have a nice algo-like implementation of Lisp, but people got so into the S expression, AST part of it, that they never wanted anything else. Back up there real quick. Brian Hayes, this is from an article called The Semicolon Wars, and he has a great quote there. It's not the original quote. I actually rearranged it so that it would be functionally correct, so you have to read it from the bottom up. But yeah, he said, what the world needs, I think, is not a Lisp with fewer parentheses, but an English with more. But people are always complaining about the parentheses. I can tell you parentheses blindness happens within 2 to 4 weeks, so just give it some time. But, on Erlang, really? So Robert had a great quote in a blog post, and he says, yes, I have implemented another syntax front end for Erlang, but it is Lisp-based. It's quite a natural thing to do. Lisp has such a simple and powerful syntax, so how could I not do it? And it skips past all the rhetoric and just gets right to the experimental scientist in all of us. Why not? Let's try it. Not yet, because before we dive into LFE, I want to explore a little bit wider context with you. And that's how we got to LFE. This was not the year that Lisp was invented. That was 1958. But this is when it got its interpreter. John McCarthy and some of his grad students have been hacking for about 4 years, and someone had this brilliant idea of putting together, I'm pretty sure this was the year, I might be mistaken, but I'm pretty sure this is the year that they got the interpreter going, and that was essentially the unofficial death of any future for M expressions. But what else was going on in 62? Oops, did I lose something there? Huh, might have to. Okay, 62, this is what we were driving. I might have lost my speaker notes here. Hang on, bear with me. And that is actually a Volvo P1800. It was a very sporty thing. And there we go. Okay. Back and running. So that's what we were driving. What were we wearing? Nice. This is how we were computing. It's an IBM 704 in all of its massive glory. Bestsellers list. Another bestsellers list. So in the world of Lisp 62, we just published the 1.5 manual. Within a year, Lisp was implemented on a PDP-1, and they were already doing AI problems. That was the whole purpose of what McCarthy had wanted to do, was really solve some of the tricky AI problems. To give you a sense of scale, this is a very different technological world than the one we live in now. ENIAC was a press sensation in 1946. Computing had lived, by this point, computing had lived in the minds of the public for only 16 years, like all of computing. UNIVAC, the first successful computer, commercial computer, had shipped in 1951, which is 7 years before Lisp was conceived. And IBM's first mainframe, the 700 series, had shipped a year later. And so this is just shortly after this time period. Everything was new. And Brian's tweeting. Here we go. Okay. Come back. It's okay. Right, so the 704, Lisp was implemented on this, was billed as a 40,000 instruction per second machine. There were about 10,000 computers on Earth at this time, which works out to 6.7 times 10 to the negative 17th instructions per second per kilogram of planet. If you were to convert this to length, you'd be looking at about 7 atometers. And that is around the same length that you have with a nuclear weak force. So we are down in the tiny, tiny Planck scale. Jump ahead, 25 years later, the birth of Erlang, 1986. This is what we were driving. And Sherrod Belafonte was wearing this. And look who. He should have made the cover of a magazine. This is what we were computing with. Just about ready to fall from grace. The rise of the clones was happening. And I couldn't find a picture of a 750, because Erlang was actually implemented on a 750. But this is as close as I could get. And in fact, it was implemented on a VAX 750 running BSC Unix. It had 16 megabytes of RAM and 2 512 megabyte disks. I had to ask Joe about that, and Joe had to actually ask Mike. So this is what we were reading. And the very famous Common Lisp by Guy Steele came out right around this time. And this is what we were writing. You can't see it at this distance, but this is the first version of Erlang itself. The world of Lisp, things had really blossomed. This was essentially the time when the Lisp machines were taking over. Everybody was doing a Lisp machine. Texas Instruments was into it. They had licensed it from I forget if it was Symbolics or Lisp Machine Inc. I think it was LMI. We had an operating system, compiler, network server, editor, all this stuff in Lisp itself. The AI winter hadn't set in, still 3 years away. Oh, symbolics.com. They were the first registered domain on the internet. Okay, sense of scale, 86. We're looking at a VAX 11750. 31 million computers on Earth, just 25 years later. This gives us that great figure, 5.2 times 10 to the negative 12th instructions per second per kilogram of planet. And this is about 5 picometers, which is converted to length. We're looking at the radius of a helium atom. Skipping ahead again, 10 years after the AI winter, Lisp started making headlines at this point. This time period saw the birth of LFE, and as well as Clojure. Haskell had a version of Lisp as well. We were driving nicer and nicer cars. Vogue. Look at this is what we were wearing then too. And this is what Lisp was written on, I think. It's the XPS, right, Robert? Yeah, okay. So Dell XPS, a long way from the 704, IBM 704, and the VAX 750. This, believe it or not, was on the bestsellers list, so literature had reached new heights. And I have not read this one yet, but it's on my list. So some of us are reading this. This came out. So the world of Lisp was quite huge during this time, a lot of changes. I'm going to skip past a lot of this, but they're in the slides if you want to go back later. Quite impressive. I only scratched the surface here. There's 3 slides of major bullet points that happened during this period. The last one is for us here, it's Robert. And in fact, Erlang and LFE had influenced the Scheme community, and they had produced the Gambit had produced Termite, which was based on lightweight threads in Erlang. Sense of scale. Huge changes. The processors had made great strides. 1 billion PCs, almost 300 million smartphones. 1.3 times 10 to the negative 5th instructions per second per kilogram of planet. And that brings us into the micrometer range. This is the typical size of fog or a cloud water droplet. Just a few years later, 6 years, but a lot's happened. As big as it was in 2008 for Lisp, it's been even bigger since then. We see there's lots of big things. In the previous slides, I'd mentioned how there's an acquisition by Google for a Lisp company. Lots of things going on. Cores are everywhere. So in these 6 years, with all these changes, we're seeing a completely different world. We're now at the size of human hair or bacterium as far as the analogy to length goes. And this is kind of mind-blowing. In 50 years, we have seen this change that has taken us from something the equivalent of the Planck scale all the way up to living organisms. That's something the universe took 13 billion years to do or so. That's a big change. Very different world. Is it still a world for Lisp? Lisp was born 3 years after the death of ENIAC. It's been with us from the start. We can't kill it. There's been a lot of attempts to. Dead simple syntax. The beauty of Lisp for me is it's homoiconic. What got me into Lisp originally was genetic programming, and the homoiconicity allows you to do some really phenomenal things with generating programs. And of course, as everybody knows, you can quite literally write a compiler in the morning, a DSL in the afternoon, and it is the candy store of syntactic sugars. I've been really resisting the urge, but I have already 2 macros that give us some nice syntactic sugar in LFE. And this is a common phrase you'll hear, is it's an ultimate language lab. Why LFE for Lispers? The actor model. You've always wanted it and you know it. OTP. For Erlangers, that's a little bit different question. Gotta play the fun card. Little syntax change is always nice, but you don't have to lose your platform. You don't have to go to Clojure and learn all the JVM. You can still play with a Lisp and stay right at home. Now, we finally get to see some LFE. You've got the backstory. So here's what numbers look like, different bases, operations on them. Is this legible? I can't really zoom, so I apologize if it's not. Okay. Atoms and strings, very straightforward, borrowing from Common Lisp here. Bit packing, this was taken from Joe Armstrong's book. I hope I got that right. I'm pretty sure it was in his book where this example was. So that's the packing, unpacking. You can see there's some pattern matching taking place in the let. Lists. This is the bread and butter of Lisps. So this is how you manipulate them using, you can see the calls into Erlang itself. More Lisp manipulation, the famous car and catter, cons. Records, you can use Erlang records. This is creating a new person record, setting some data on it, changing some stuff, which of course is not mutable. And pattern matching, there's a bunch of these. I'm going to zip right through them, but this is a standard let. Let has been modified in LFE to allow for pattern matching. So if you're familiar with lets, you can see there's an extra little structure in there to accommodate the data assignment. And these cascade through the rest of these various forms: case, cond, def fun. And if you have a function with, let's see here, I want to get this right, the same arity, like you can Erlang, you can create multiple functions with the same arity. In LFE, what you do is you actually create a block like this, where if you have a function where you want to define a match across a pattern with different arities, you do it in the same function. And so this would be an example of that. You can't actually, as far as I recall, you can't actually do multiple functions of the same arity. Right, okay. Robert's got a little frown, so I might be saying something a little bit wrong. Gosh, this is the one that finally sold me over to LFE, was being able to do the message passing in this kind. It was so clean. And I'd seen a lot of stuff in various Lisps that were trying to do what Erlang was doing, and this was just absolutely phenomenal, quite beautiful. And I was hooked after I saw this example. Macros. This one actually lets us do very closure-like unit tests in LFE. A very simple macro. And again, this is what you would have normally without this macro. And over there, you can see a little bit of sugar. You don't have to do the boilerplate of the under test and the parens. Similarly, if you want to be able to, like, this is from a project that defines HTML elements using S expressions. And it generates 3 arity functions in the macro, simple as it can be. And you have all the possibilities you can to create your HTML as S expressions. The church numerals. Quick little glimpse. This is from the examples in the source code, LFE source code. And again, this one and the following one are also an HTTP async request. Uses plist to gather the results, bidirectional messages. And of course, we all know this LFE runs on Erlang. And this is a piece of the Erlang code in LFE that I was digging into recently, adding some more macros. I will explain this very, very briefly and partially incorrectly, but this is LFE's AST syntax, basically, in Erlang lists, defining list macros used with records that are also using Erlang macros. So, yo dog, I heard you like meta, so I got meta for your meta. This is what Erlang looks like inside LFE, and it's fairly easy to hack on. Let's take it for a drive. If you really want to get to know LFE, the next logical step is to create a project with it. And you can't just jump right into that. I got to tell you about the dependencies. They're not too long. I suggest curl. I like curl. Lets you do multiple Erlang versions on the same platform without having to mess with, Rebar is going to be absolutely essential for right now. All the LFE examples that we've put together, the project that we put together, use Rebar itself. Very, very easy to get up and running with just a quick download. LFE, obviously, but if you're using the standard tools, then you don't have to worry about this. LFE will be downloaded for you. And there's a new tool we've put together called LFE tool, and I'll show you that right here. So here's an example. If you want to run scripts, that's the first thing I'm going to look at is scripts. you're going to want to have LFE installed system-wide. If you don't think you will ever use scripts, then don't worry about it. You don't have to install LFE. You'll just use LFE as it's downloaded in rebar. And so if you want to do the script thing, download it, set the environment variables, install LFE to your whatever bin directory you prefer, get LFE tool, install it, and you can do an update. It updates itself if you have it installed. And so yeah, now we'll take a look at what you can do with this. And these are the different options we're going to explore very quickly. Creating a script, running it, creating a library, and creating a service. This is as simple as it is to create an LFE script. Run it through the LFE tool. It's going to generate the script for you. This script that it generates is actually out of the examples in LFE. Pass it, it's a Fibonacci, pass it 42, get your response back, plain and simple. This is what the script looks like. It's generated, it's got the hash bang, some options you can set. I think I can scroll to the bottom here, just a little bit more usage. Fairly straightforward. Okay, and when it, all right, so the next step, creating a library. Library projects have a whole, that was a single file, and this creates a subdirectory with subdirectories and all the appropriate files for getting started. And by library, I mean Erlang code that you're not actually calling GenServer and that sort of stuff. Something to be used and imported in another project. The filtered, after we run the tool, new library, mylib, these are the files that exist. Taking a look at some of the code, here's some broken code that is inserted intentionally so that when you run your unit tests, this unit test will fail. TDD from the start. And creating a service, very similar. Instead of library, you say libtool new service. Bam, here's your new OTP service. It's a lot of boilerplate. Here's a quick look at some of the my service app LFE file. And here's the API section of the server file. You run this and you actually have a functioning OTP app, and you can take it for its paces here, make a couple of calls, and it reports the output as it is defined in the API, the little test API. So if you want to run an OTP service, very, very quick and easy in LFE. So that's what LFE looks like. Let's see what it looks like in a bigger context. Using LFE tool, we'll create a new project called Cloudy. We're going to use Amazon's web services first. So we add a new dependency. Update your rebar tool. I'm sorry, your rebar config file. Right now, you have to manually update the make file with your new dependencies. I have plans to create a series of rebar plugins in LFE that'll do this stuff for you. But for now, update your make file. You run the script, create your tool, LFE tool, create your code, and now you just go in here, and the file that's created for you, cloudy.lfe, add your implementation. And that just makes calls out to AWS. Make shell. You're running in the REPL right now. Slurp in the file that you just added the function to, pick an AMI for Amazon, and tell it to run that instance. You get a response back with all the metadata. And to double check, hop over to your console, your AWS console, and there you see the instance running. Again, from here, the world is yours. You know what to do on AWS. Make all the changes, configurations you want, create an image that has this stuff pre-installed, and you are off and running with a production instance of Erlang and LFE. Rackspace Cloud, competitor, very, very similar situation. There was no SDK for Erlang or obviously LFE for this presentation, so I just simply started creating one. It's a partial implementation. It lets you create instances so far, deletes maybe not, but basically enough for this demonstration. Make the changes to your make file. Also, yeah, you need to, this actually includes Jiffy, and so Jiffy, for right now, I haven't found out why, but Jiffy needs an extra compile run inside the project directory itself, so you update the make file target here to do so. Then, just like we did for AWS, we create a little function here that's going to make your instance in the Rackspace cloud. It is a little bit more verbose, but because Rackspace does not assume that you are using a particular region, it makes it fairly easy for you to swap out regions, whereas AWS code is a little more cumbersome in that regard. Jump into your REPL, make the request, please turn on this instance, and bam, you get your nice 202. Pop over to check your console, and sure enough, there it is running. Same story from here. You can create your own images, make everything spin up. So we've just interfaced with 2 cloud instances. We know how to essentially, with whatever configuration management system you're using, we know how to push LFE code and Erlang code into the cloud. We can run these OTP applications. What might we run? Let's say you want to build an SOA. RESTful services. Can you do this with LFE? Absolutely. You wouldn't believe how simple it is. We're going to use Yaws here. Dead simple. And it's awesome. I love it. Yaws was actually my first experience with Erlang back in 2006, I think, was when I read that blog post that blew everybody's minds. The comparison to Apache. Again, update your dependencies. Update the target. You need to, for Yaws, needs a couple of directories. So you create some directories that you need. Create a configuration, Yaws configuration, local directory, etc, yaws.conf. And then all Yaws really needs is, to integrate, is you need to define an out function that takes a single parameter. That's it. End of story. The rest is just reading the docs on what sort of content types you want to return, that sort of thing. So we've created something simple here. We're basically going to extract the path info for our REST, path info and method. Then we define some function for routes. You know, this is the classic coffee shop example converted for Volvos, you know, given the theme here. So order with no ID, order with an ID actually passed, orders to get a whole list of orders, and then payment, orders that you're, an order that you are going to operate for a payment. It's a classic example. I think anybody that's done REST has seen this example on the web. Each route here makes a call to an API function. And here's the example of the API function for order with no parameter, order with an order ID, additional arguments that aren't used are passed here. And you can see it's doing the pattern matching against what your HTTP verb was, get, put, delete. Likewise for orders, if you want to check the status of all the orders, get a list of all orders that are pending, and then your payment API, get and put. These are just utility functions implemented to help support this. This is all running code, by the way. If you go to OB1 on GitHub and do OB1/Cloudy, all this code base is there. It actually runs. You can check it out for yourself. The make target that we created for running up a Yaws dev server, go ahead and fire it off. And then let's just walk through and make sure that all the code you saw, that's all it takes, and make sure everything there is running. Run curl against the various endpoints. And bam, here we go. Data, you just made a new order. You got the status for your new order. You've updated the order with a put. You're getting a list of orders. Payment, getting the payment. Paid for an order, delete the order now that you got the pay. And you've got your Volvo. Okay, so all it took to get to the Amazon Rackspace instances was a couple of functions. This is barely scratching the surface. There's a lot more to do there. But likewise, the REST server, setting up a REST server, dead simple. Again, there's a lot more to cover there. Obviously, the implementations, calling out the data sources and whatnot, but you got the idea. I had planned originally to dive in a little bit more deeply. There's some areas of exploration that I wanted to cover and didn't quite have enough time. But I wouldn't mind chatting about that right now. And the first of these that I wanted to cover was hierarchical task networks. This is going back to AI. And these guys are sort of like the new planner, if you guys are familiar with planners from the 70s and a little bit in the 80s. Alan Kay has talked about these. Brett Victor, if you've seen that The Future of Programming video he did at the Dropbox conference last year, has also talked about this. And they have this dream. a world without APIs. What does that mean? Submitting goals to a service, goal-oriented programming, and letting the services behind the scenes do the calculations and say, oh, these are the steps that, or sorry, these are the goals. Let me calculate what the steps are necessary to meet those goals. And this is computers talking to each other. If you've seen the Alan Kay video, he's like doing all this, like, computers should just be talking to each other. Programmers no longer having a need to use APIs when talking to services. Kind of a mind-blowing concept. The first step would be humans not having to program APIs, but the steps after that are actually services that can talk to each other, do auto-discovery, and eventually we could get to the point where you do not have the vast overheads in services communication. Development can focus on other areas. This is not actually a pipe dream. UMD, University of Maryland, wrote an award-winning HTN in 2002 in Common Lisp. They've recently done a Python version. It's pretty okay, but a little bit lobotomized. I've got an LFE implementation that is like 90% done. I can't wait to get the extra 10% because I'm going to go back and rewrite the whole thing from what I've learned. But this is, yeah, Maryland's. This is all stuff. This is what it looks like in LFE when you just run the goals. I've got a couple of bugs in this, and then I'll be ready to release it. So that's a fascinating area of exploration, and there's a lot of interesting things to do there with services talking to each other. Rebar plugins, started hacking on this stuff for this talk as well. Wanted to get something interesting, but I only have a few dead simple examples. You can actually write Rebar plugins in LFE right now. This particular Rebar plugin does this. It makes sure that anything that you are going to run only happens in your actual project directory, which is a little bit trickier than what you might imagine because by default Rebar runs across all deps and the current directory. This does the inverse. This code right here, as you can see with the swap between true and false, it runs in every single directory you can see by the output besides your current project directory. And again, very useful things when you want to run deps or include things in makefiles or not have to use makefiles. Another project that I started, building a REST client. Again, this is all, you would not believe the amount of yak shaving I did for this presentation. Building a REST client, this is already done. I wanted to do something with the Neo4j database, and I had already written the Rackspace and the OpenStack clients, so I started pulling out code into a common library, LFE REST client. Yeah, I've already converted one of the libraries to use it. More to come. Genetic algorithms, this is what got me started in the first place. And in fact, this is probably genetic programming is a better way to say it. Genetic algorithms technically is the string manipulation, but it's they're isomorphic. You're manipulating programs instead of strings. Robert and I actually chatted about this a while ago, and I showed him some example code. He was helping me debug some of it, I don't know, about a year ago or so. There's a huge amount of work that's been done with GAs and GP. John Koza is the most famous for this. He's got literally volumes of this stuff. I've got his first volume, and it's about this thick, and I've made it through maybe 200 or 300 pages. Lots of stuff to mine. People just haven't even seen anywhere in the real world. Almost all the examples are written in Lisp. Again, homoiconicity. And this is the part that intrigues me most. It's like we could actually do mini lab scientific programming using distributed processes from Erlang. And that's what draws me to Erlang and the ability to run these things. So, quick examples, I actually do have some code that's working right now. This is all randomly generated code. I don't have the fitness functions done yet, partially implemented, replacing nodes, none of that's done, crossovers. This is all stuff I have to do. Evaluating generations. So, I've got some time, just a little bit. Covered a lot. Lisp, is it still interesting? How we got to LFE, taking a look at itself. You guys loved it, right? Took it for a spin. Racing ahead with bigger projects, and a little bit of off-road there with the research projects. I want to wax a little bit philosophical in closing, and I hope you forgive me for this. But modern computing started with a war. We proposed violence as a solution to violence. We're working with very, very powerful tools, code that can modify itself, systems that can spin up processes across the entire globe. Like if you guys have seen that blog post by Joe Armstrong where he spun up all these Erlang processes on PlanetNet. Extraordinary concepts, homoiconicity, the actor model, metaprogramming. We can actually take a different path than what we started with. We can rewrite our own history. One of the middling researchers in the actor model in concurrency was Gul Anka, and he wrote a dissertation for his PhD in 1985 that's just brilliant. He is currently a professor at Illinois, Urbana. Started his career at MIT and switched to Michigan when his professors moved over there. Throughout his studies, he was left with a deep impression regarding the power of this particular model of distributed computing. The actor model blew him away. Inspired by Carl Hewitt, as you might imagine. He's got some great quotes from his preface, and this is the philosophical part. And he made some great observations and made an altruistic plea that resonates. Again, he talked about the power of computing, the possibilities that come out of all this incredible stuff, and he noted our history. And this is the quote: somehow we have to develop an ethic that values compassion rather than consumption to acquire reverence for life itself. And his vision is unusual, but it's compelling, especially given the context of our industry's early beginnings. And our future is open source, and this is how I think we can accomplish the goals that he was looking at in '85. The open source community was barely there. A lot of stuff from MIT had spread out across the globe, but nobody had solidly defined it. And working together, as we are with conferences like this, we're actually helping this guy's dream come true. Lisps make great language labs. Distributed fault-tolerant platforms are precious, precious things. We're heading down the road towards incredible complexity in computing. Emergent systems are the next step. And my plug for LFE, we get Lisp, we get Erlang, we get the language lab, and we get a distributed systems lab. It's the perfect combination. Go make something awesome. This is my contact info, LFE, mine, and thank you. Any questions? Robert's here so he can answer all of them.
None of the things that Duncan's done.
Yeah.
So could you explain some of the rationale behind, there's some artifacts of the language, there's a colon operator. So
Right.
as someone who's done production, Common Lisp, it stands out, okay, is
Right.
that supposed to be fun call? Why
Right.
do it that way as opposed to just parse out the module name?
So the question was, why use some of the syntax that is present for instance, calling to Erlang? That is actually a Robert question. It was the most convenient way to, as far as I recall, to actually be able to make those calls into, and it's not the fun call. The fun call and apply can both be done outside of that, and you actually do have to, if you're in the REPL and you can't yet, Robert's working on stuff where we can define functions and macros in the REPL, but right now you can't. So you define a lambda, and you can just do a fun call on the lambda that you define in the REPL. Same for apply if you want to, in macros, if you want to do the the unquote list, you can do the apply with all those. But Robert, if you wouldn't mind.
Just because the way I see it from the colon thing you get in Common Lisp, that's sort of separating the package name and a symbol in that package. We don't have packages. We don't have namespaces. So I was very, very cautious about doing that. So that's the colon front. It's just colon says it takes a module name and a function name. Well, it doesn't try to package handling. But conceptually, can't you see module names as somewhat equivalent to the Common Lisp package name? Yeah, but the packages, all the symbols in Common Lisp are moved with the package. Right. Really, you don't have global symbols. Right. Whereas Erlang atoms are global, so that's why. You could write a macro that fixes it. Yeah.
I've thought about that.
So there's a guy who wrote a macro, didn't import the macro. So you import a module, and then you can use the module name, colon, function name, and turn it inside your code. It's just that I was feeling very pure. I didn't want to make it look like something else.
Yeah, and the Erlang code, the LFE Erlang code that does that, the parsing is very easy because it sees that form as a colon and just falls right out. There was a question over here. Was it you, Brian?
Yeah. So you're certainly calling to Erlang from LFE. Is it also called to
Yes. So the question was, it's possible to call to Erlang from LFE. Can you do the reverse? And yes, you can. The standard syntax, the convention in Lisp, Common Lisp, is to use hyphens in names. So this doesn't actually work for atoms. You actually have to quote atoms. Yeah, you have to actually quote your atoms. So the module names are atoms. You quote them, single quote, in Erlang proper, and you can actually do the call. So I've actually run LFE libraries I've created in straight up Erlang, and just by doing that sort of thing. So, and so you have, it looks a little bit funny when you have names with hyphens in them, but yeah, a little more verbose. But yeah. Any other questions? Yes.
So I understand that Erlang itself was worked through in Prolog.
Mm-hmm.
Let's say the language features were first experimented in. Are there any language features that were maybe the experimentation started in LFE or something similar, and have sort of are slowly working their way into a future Erlang? What sort of things can we learn to? How can we improve Erlang?
Right, yes, that's an excellent question. I'm probably not the right person to answer that. However, have you seen the Joe Armstrong's blog post about Elixir and how he found it very inspiring? So I think that is already happening with Elixir. And in fact, Elixir was originally inspired by LFE. I think he made some early commits to LFE itself, Jose did. Robert has recently taught a course on Elixir or prepared one and will be teaching. And he's actually gotten some new ideas for LFE based on the stuff that has been done in Elixir. I would imagine with the cross-pollination happening here that we're going to see more and more of that. But that's an optimistic personal view. So.
I steal ideas from anywhere.
Excellent. Well, thank you very much.